even though I'm recording, feel free to stop and I could re-record. So especially if I make a mistake, please stop me. That way I could fix that mistake. It doesn't get recorded. Anyways, we're still on section 8.6. Yesterday we did video 1, which was solving rational equations. The previous class I did video 2, which was focusing in on some questions on inequalities. We're going to do video 3 on inequalities as well. That way I have all the videos uploaded to YouTube, uploaded to Google Classroom. So if we look at the worksheet, the first part of the worksheet were all equations. They all had equal signs on them, right? Solving equations. How do you get rid of fractions? You multiply by the denominator of the fraction you want to get rid of. But today we're moving on to solving inequalities, which is on the back side of the worksheet, right? And on the previous video, I already explained number 19, number 20. So let's jump to 21. And before we begin on 21, here are the steps. It's a lot more complicated and a lot more time consuming than just getting rid of fractions, right? Step 1 is you solve it the way you solved the first side of this worksheet, solving equations, right? You want to get rid of a fraction, multiply everything by the denominator. It makes the fraction disappear. And you're going to get an answer. So step 1, solve it, get an answer. Step 2, go to your denominators, set them equal to 0 and solve the denominators, set equal to 0. And you're going to get more answers, okay? And step 3, plot all of your answers on a number line and test the areas. So we're going to do that with number 21 right here. So step 1 is to solve it. I need to get rid of fractions. What do? Multiply everything times v. Okay, so I'm going to go times v here, times v there, times v right there. Okay, so I end up with v times 2, that's 2v. And then we have a minus, and the v's cancel out, no more fraction, minus 3. You have the less than symbol. The v's cancel out. I have a 5. Now let's solve for v. Let's get rid of the minus 3 by doing plus 3. What you do to one side, do to the other side. You have 2v is less than 8. Final step, get rid of the multiplication of 2 by dividing by 2. What you do to one side, do to the other. You end up with v, and you don't flip the inequality. As a matter of fact, you don't flip it because you didn't divide by a negative. But you could have also just changed this to an equal sign and just put an equal sign there if you wanted to. All right, so you could have put an equal sign and have a v equals 4, or you could keep the inequality. That way it also helps you when you're getting your final answer. But anyways, this is our answer right here. V is less than 4. And then if you go to step 2, it says set the denominators equal to 0 and solve. So right here it's simple because the denominator is just a v and the denominator is the same denominator, just a v. So it's a little bit more challenging when you have, like right here, you would have to set the x plus 4 equal to 0 and the x plus 10 equal to 0, and you would get two answers, negative 4 and negative 10. But that's already recorded on a different video. So let's go for this easy one that we're doing right here. So we're going to set the denominators equal to 0. As a matter of fact, let's label our steps here. This was step 1. We solved it. Let's move on to step 2. This was setting your denominators, the v, set it equal to 0, and you solve it, but technically it's already solved, v equals 0. And again, if you had a different denominator, like let's say v plus 2, well, then you would say v plus 2 equals 0, and you solve that as well. But right here, it's the same. So the only answer you get right here on step 2 is v equals 0. Like you set your denominator equal to 0 and solve it. It's already solved. That's your answer. So now we can move on to step 3. Step number 3, it says plot all answers on a number line. This one's really easy because there's only two answers. There's the v equals 0 and v is less than 4. So here's 0, here's 4. I plotted them on my number line. Like I said, you could have said that this was equal. That way it would say v equals 4 and you just plot the 4 right there. So it's not just plotting your answers on a number line. It says, and test the areas. So right here, because there's only two critical points, two answers, you have three areas. The one that's on the left side of 0, the one that's between 0 and 4, and the one that's on the right side of 4. So you need to actually test the values on those areas. So give me a number that's on the left side of 0. -1 is the easiest, I would say. So let's put a little -1 right here and let's test it. And just to be thorough, I'm going to write out right here what am I doing? I'm going to test negative 1 by plugging it in. I'm not going to write this every single question, but right now, since it's the first one that you guys are saying on this video, I'm writing on a test negative 1 by plugging it in. Plugging it in where? Into the original inequality. So I'm just going to rewrite the whole thing. I'm going to rewrite 2 minus 3 over v, but I'm going to leave that blank. It's less than 5 over v. I'm going to leave that blank. Why? Because we are testing the v value of negative 1. So let's put a negative 1 where the v used to be at and where the v used to be at down here and down there. So we're going to put the negative 1 right there, negative 1 right there. And let's do the math here. Oh, wait. Let's do the math here. What is 3 divided by negative 1? That's negative 3. And if you put a negative in front of a negative 3, that'll change to a plus 3, correct? And if you're confused with that, just use a calculator. Just go 2 minus 3 divided by negative 1 with the calculator, hit equal, and it'll give you 5. Because you end up with 2 plus 3, which becomes 5, okay? And when you do this side over here on a calculator, 5 divided by negative 1, well, you should know what that is. That's a negative 5. And we take the inequality, bring it down. And what do you think of this? Is this a true statement or false statement? That's false. False. That does not work. The positive 5 is not less than negative 5. So you go back up to here to the value that you just tested, and you're going to say, you could either say the word no, or I'm going to put a little red X. That means it doesn't work. It does not work, okay? So now let's test the area that's in the middle between 0 and 4. And okay, so this is some work that you need to show on a test, because that's how you know that this area did not work. Let's test another value between 0 and 4. Give me a number to plug in. 2. What would be even easier to plug in instead of 2? Because you don't want a 3 over 2. A 1 is easy, or a 3 is easy. But over here, a 1 and a 1 would be better, because that would just be 3 over 1 and 5 over 1. So how about that? Let's put a dot right here and put a 1 right there. Let's test that number 1. Let's see if it works. And again, I'm going to write out test the number 1, okay? How? By plugging it in, but I'm not gonna say that, but I'm just titling it. I'm testing number 1. So let's rewrite the whole thing. Now you could go back to the original or go back to this one and just rewrite it, but instead of the negative ones, we're gonna put a blue positive one. Okay, so you have 2 minus 3 over the blue positive 1 is less than 5 over the blue positive 1. So we're gonna plug in blue positive 1, blue positive 1. What do we have here? We have 2 minus 3 divided by 1 is just 3. So 2 minus 3, that's negative 1. Bring down the inequality. 5 divided by 1 is 5. What do you think of this? Is this true or false? That's true. True. So that works. That means that this guy right here, it does work. So I want to put a green check mark. Or I could write out the word yes if I wanted to, right? No, it doesn't work. Yes, it does work. Okay. Now, I could test the value over here. Like pick a number to test over here. 5. 5 is definitely on the right side of 4. So if you wanted to, you could say test the number 5, but I already know it's not going to work. I already know it's not going to work, but let me show you that. Let me prove that. 2 minus 3 over 5 is less than 5 over 5. Okay, so you have 2 minus 3/5, and that should be less than 1. And you can do this on the calculator. As a matter of fact, for the sake of time, I'm going to type in on a calculator 2 minus the fraction 3 over 5, hit equal. That's 7/5. And you could hit the SD button on the calculator, and it'll change it to a decimal. And that decimal will be 1.4 is less than 1. And obviously, that is false. So that's false. So that means no, it does not work. So when you do test the number 5, it did not work. So you'd put a red X right there. You would say, no, it doesn't work. But I already knew it wasn't going to work. Why? Because on the original inequality, I actually kept the inequality. And you already know that your V values have to be less than 4. So it can't be greater than 4. I already knew it wasn't going to work based on this original one. But if you wanted to, you could have just put an equal sign. Then you would have to test every single side. But from the beginning, you know that the V values have to be less than 4. So it has to be to the left of 4. So where are your answers at? They're between 0 and 4. So according to the testing of the areas, we could now give our final answer for number 21. Final answer is, well, the x values, or I'm sorry, the v values in this case, have to be between 0 and 4. How do we write that? 0 is less than v is less than 4. And that is your final answer for this question. And if you think that was a lot, it's actually one of the easiest questions with regards to inequalities. Number 19 was way the heck longer because you had more answers by setting the denominators equal to 0. That means you had more areas to test. So it was a lot more work. You could check that out on a different video. Let's try number 22 right here. This is also pretty easy. Why? Because it doesn't have like an n plus 5 and an n minus 3. If you had an n plus 5 and an n minus 3, you'd get two more different answers by setting the denominators equal to 0. So you'd have more values, more areas to test. So right here, we're going to just start step 1, solve it, multiply everything by what? N. So this times n, this times n, this times n. Everything times n. You're going to end up with the n squared. This cancels out. Well, maybe I shouldn't. I'll cancel out with the yellow. That way you can still see it. And you'll end up with a plus 3. And then you have the less than symbol. Or you could put an equal sign, right? Let's just put an equal sign. And then the n's cancel and you get a 12 over here. So you could switch it to an equal sign or you could keep the less than symbol. It's totally up to you. Let's now solve this thing, get n by itself. So we're going to subtract 3. You're going to end up with n squared equaling 9. And how do you get rid of a square? Square root. But when you apply a square root, when you apply a square root in an equation, you have to put a plus or minus in front of your answer, and the square root of 9 is 3. Yay? So technically, you get two answers. You get positive 3 and negative 3. That's what plus or minus actually means. So we're talking about n equaling 3, n equaling negative 3. Okay? That was step 1. Let's move on to step 2. Step 2 is to set your denominators equal to 0. And like I said, other questions have like an n plus 3. You would have to set that equal to 0. Maybe a 2n minus 5. You have to set that equal to 0 and solve. But right here, you just set these guys equal to 0. And it doesn't get easier than that because there's nothing to solve. That's your actual answer. Okay? So we really have one answer, two answers, three answers. Technically not answers, but critical points on a number line. This is where we go to step 3 and plot them on a number line and then test our areas. So obviously we have 0, we have negative 3, we have positive 3, and we need to test some areas. So let's test an area that's on the left side of negative 3. Give me a number to plug in right here on the left side of negative 3. Negative 4, okay, no problem. So let me write out what I'm doing here. I'm gonna test negative 4, okay? How am I gonna do that? By plugging it in. Let me rewrite this original one, but instead of n's, I'm gonna leave blank spots because I'm gonna plug in a negative 4 in there, okay? Oh, I have an n right here as well. So negative 4 instead of the n plus, so I have plus, then I have a fraction, 3 on top over that n value, in this case, negative 4, we're testing negative 4, is less than 12 divided by n, which in this case is negative 4 that we're testing, 12 divided by negative 4 that we're testing. Now, again, all of this could be done on the calculator, okay? You could type in negative 4 plus 3 over negative 4, hit equal, it'll give you a value. Then you check if that value is less than whatever this is. In this case, this is the nice, beautiful number, negative 3. So you don't actually have to reason through this math. Over here on this side, you have a negative 4 plus negative 3/4. Now think about that. Negative 3/4, if you change that to a decimal, that'd be negative 0.75. It's like owing 75 cents and owing $4 and owing 75 cents, you would owe $4.75. So the question is negative 4.75, again, you could do that on the calculator, is negative 4.75 less than negative 3? True statement. So this is true. So you would say true, okay? Now, we just tested the value negative 4, which is right here, and that worked, check. Okay, so you could either put a check mark, you could say, yes, this side works, whatever you want. but you know that your answers are on the left side of -3. So now let's test a value that's between 0 and -3. Pick a value. -1 looks great to use. So, and oh yeah, I also like to circle my work for where I'm testing certain values. So here I'm going to say test -1. And once again, you're just going to rewrite it, but where the -4s used to be at, you're now going to plug in -1s. So that will be a -1 plus 3 over -1. It should be less than 12 over -1. So if you do this side, 12 over -1, that's -12. There's an inequality. 3 over -1, that's -3. There's a -1 over here. So -1 plus -3, or just -1 minus 3, that's -4, is less than -12. What do you guys think of that? Is -4 less than -12? No, that's false. So when you tested this value of -1, which is clearly on the inside between -3 and 0, that did not work. So I'm going to put a little red X right there. Or you could say, no, it doesn't work in there, right? So my answers are over here, not in here, but now we need to test over here. Give me a number between 0 and 3. 1. Okay, so let me circle this in. That was me testing -1. Now let's test +1. Let me write that out. Test +1. Let me change colors here. So wherever there was a yellow -4, I'm going to put now a blue +1 right there. So it's going to be a 1 plus 3 over blue +1, and that should be less than 12 over blue +1. It's really easy to divide by 1. So what do we really have here? We have 1 plus 3, because 3 divided by 1 is 3, is less than 12. So is 4 less than 12? Yes. So that's true. True. So that means that by us testing the number 1, it worked. So green check mark, or you would say, yes, my answers are between 0 and 3. Okay. Now let's test the final one. Plug in a value that's greater than 3. So give me a value greater than 3 that we could plug in. +4. Okay. So let me test. Let me just put a +4 over here. Let's test it. By the way, let me circle that. That was testing 1. Over here, test +4. Going back to a yellow. So we're going to rewrite it. You're going to have a +4 plus 3 over +4 is less than 12 over +4. And you do the math. That's 4 plus 3/4. That's like saying $4 plus 75 cents. That's $4.75. Or you could even leave it as 4 3/4, whatever you want. Okay? 4 3/4, right? If you just say 4 plus 3/4, that's 4 3/4. What about 12 divided by 4? 12 divided by 4 is what? 3. Is 4 3/4 less than 3? No, that's false. 4 3/4 is greater than 3. So what does that tell you about that value of 4? That area does not work. That's why I put a red X right there. And you could put a red X. You could say no, whatever you want. This area does not work. So where are the areas that work? The areas that work are to the left of -3, to the left of -3, and between 0 and 3. So you have to write that as two separate inequalities. So here's our final answer. According to the testing of the areas, you would say X, it could be less than -3, comma, and then over here is a compound inequality between 0 and 3. So you can say 0 is less than X is less than 3. Wait a minute. I apologize. We didn't start with X's. The original had N's. So technically, the X's should be N's. So you should say N is less than -3. 0 is less than N, which is less than 3. I mean, if it were an actual test and you just typed in X's, I'd give you the credit anyway. But to be perfect, this original question didn't have X's, they had N's. So the final answer is N is less than -3. And also N is between 0 and 3. 0 is less than N is less than 3. What do you think? Okay, nice. Should we do another or no? Yes. No? Anybody? Yeah? Okay. 24? Let's do 24. Multiply everything by what? by x. Now, if you were to multiply by this bigger 2x, it actually gets rid of all three of them at the same time. You guys want the quickest route possible? Multiply by 2x. You see, if you just multiplied by x, that would cancel out. And right here, the x's cancel out, but you still have the fraction 1/2. So if you did 2x, everything cancels out. Check it out. Times 2x, times 2x, times 2x. Everything by 2x. The 2x's cancel. We end up with 1, no more fraction, is less than. Over here, the x on top cancels with the x on the bottom, but you still have 2 times 2, so you'd have a 4 right there. And the 1 times 2x is 2x, so you're going to have a minus 2x right there. And here's your inequality. Let's solve it. Let's get the numbers to the left side. I'm going to subtract 4, subtract 4. You end up with negative 3 is less than negative 2x. And then we're going to divide by negative 2, divide by negative 2. So x, you have to flip the inequality symbol because you did divide by a negative on your last step. So a negative divided by a negative is a positive, so you could leave it 3/2, or you could change it to a 1.5. $3 divided by 2 is $1.50. And we should flip it to have the x on the left side and the 3/2 on the right side, but it keeps the same respect. It was opening up to the 3/2. It has to continue opening up to the 3/2 if you flip the whole thing. So you could say this is your answer, or you could change it to x is less than 1.5. Whatever you prefer. Anyways, that was step 1. We want step 2. You're going to set your denominators equal to 0. So this is step 1. Step number 2, set the denominators. We have a 2x in the denominator. So you're going to say 2x, set that equal to 0. And the other denominator is a regular x, so x equal to 0. This is easy because both of these produce the same answer, which is just x equals 0. Okay, so it's just x equals 0. So we're going to take our answers. Step 3 is to plot them on a number line. Step 3. And we're going to plot the answers 0 and 1.5 on a number line. And then we're going to test our areas. So give me a number that's on the left side of 0. Okay, so we're going to test -1. So here's -1 on the left side of 0. Let's see if it works. How am I going to do that? By going to the original and replacing the x's with that -1. So the original says 1 over 2 times x, in this case 1 over 2 times -1, should be less than 2 over x, in this case 2 over -1, and then -1 at the very end. So let's see how this works out. This ends up being -2, so 1 over -2 is technically -1/2. So you have -1/2 is less than, and right here you have 2 divided by -1, that's -2, and -2 minus 1 is -3. So you have -1/2 is less than -3. What do you think of that? That's not true, right? -50 is not less than -$3, right? So that's not true. That means that this did not work. That means that this left side of 0 is not part of your answers, okay? Now let's test the value between 0 and 1.5. What would that be? An easy one. Testing the number 1 would be easy. 1 is between 0 and 1.5. Okay, so let's see if that works. Again, we're going to test. So I'm going to write it out. Test the number 1. How? By plugging it in. So instead of 1 over 2 times x, it's going to be 1 over 2 times 1. And then it should be less than 2 over x, 2 over 1, and then -1. All I did was replace this x and that x with what I'm testing, the 1. Doing the math, I get a 1/2 over here. And again, you could use a calculator if you want. You get a less than. And right here, 2 over 1 is 2, and 2 take away 1 is 1. So the question is 1/2 less than 1? Yes, it is. That's true. So we should be able to say that, yes, the area in between 0 and 1.5 works, so my answers must be in here. Now, you could test any number you want on this side, and it's not going to work. How do I know that? Because I didn't replace this with an equal sign, so I kept the inequality. So I know that it has to be x is less than 1.5, so it has to be to the left. It can't be to the right. But you could go ahead and test the number 2 or the number 5, any number you want. It's not going to work when you test that. So the only answer to this problem is the area that's between 0 and 1.5, or you could say 0 and 3/2. So that'd be a compound inequality. 0, 3/2 with the x in the middle and with less than symbols. So there's your final answer according to your testing of areas on a number line. I hope this helps.